Hello, welcome to episode 1 of Work From Home. Hope everyone's doing alright. This first video is going to be about this process called weathering. Now it doesn't have to do with the weather. If you look outside, we've got this type of weather happening, which is snow, right? Precipitation, but it turns out that weathering is actually different. Weathering is going to be breaking down rocks, making big rocks into smaller rocks. So this first image here is actually a satellite image of Egypt. And not just of Egypt, but we've got the Nile River with all the little cities and towns built along it. And then you can see how it kind of fans out. It's called the Nile River Delta. And the Nile River Delta wasn't there 10, 20,000 years ago, or at least it wasn't there in the way it is there now. It's actually grown out and grown out. So it's taken all of these broken rocks from down in Africa, and it's moved those little rocks further and further out until they get dropped here as they enter the Mediterranean. So I just think that's pretty cool. So we're seeing breaking rocks, which is weathering, moving rocks from the stream and the river, the Nile River. Moving rocks is called erosion. And then putting the rocks down, which is where they are in the delta here, is deposition. So weathering, breaking rocks. Erosion, transporting or moving rocks. Deposition is placing the rocks down onto whatever is beneath it. So in a stream, we would call it a stream bed. At the end of a river, we call this a delta. All right, so these are just some terms that you're going to be hearing. And we're going to just get right into it. So here's another example of a delta. We have a river that flows over here, and then it enters into a larger body of water where it deposits all these sediments. So if you came back here every year, you would actually see that this is going to continue to grow out further and further. If not every year, then every 10 years you'd be able to notice it from a picture like this. So this is a depositional environment, and all these little sediments, or all these little rocks here, came from the tops of the mountains in the background, and they were broken down into smaller and smaller pieces, weathered, and eroded, which were then moved. Okay? So you can look at these, this PowerPoint on Schoology. It's going to be posted there, but I'm going to walk you through it, so hopefully this helps you out. Just to go over some basic definitions, this is on the Nearpod lesson, which you're going to be completing. There is a definition of weathering, which is the natural breakdown of rocks, and that happens in two ways. One way is the obvious way, where rocks can bump into one another and little pieces of them start falling off. That's physical weathering, because it's a physical process where two things bounce together. There's a second process, which isn't so clear, but it'll make sense once we get to it, which is chemical weathering. Chemical weathering is when chemicals actually get into the little cracks in rocks and start to break them down with chemical reactions. And you can see the evidence of this in certain places, like rust, which we call oxidation, and in limestone caves, which actually form from the acid in the water dissolving the limestone rocks and forming those caves. We'll see pictures of that. So there's physical and chemical weathering. Physical is physically breaking down rocks, pulling them apart, smashing them together. Chemical is using chemicals to dissolve and break away the rocks. So like I said, physical weathering, we're just going to have the same material, just in smaller pieces, or the same composition in smaller pieces, Hulk smash. And these are the different types of sediments. We've got really, really small things which you can't even see with a microscope, clay sediments. This would be like what you use in pottery class and art class. And that goes all the way up to silt, sand, pebbles, cowls even bigger, and the largest things are boulders. Lucky for us, it's in the reference table here along the right side. We've got those different sizes, and they actually have their measurement in centimeters. So clay is anything 0.0004 centimeters, which is not visible at all, and smaller. Boulders are anything larger than 25.5 centimeters, which is about a foot, a little shorter than a foot, but you can think of it that way. And we're going to get into the 4 forms of physical weathering. Hopefully this is clear. I think it is. You can see, we'll see. So we have 4 types of physical weathering. We're going to start with the most important one, which is abrasion. So abrasion is what sandpaper does to different things. Sandpaper, the point of sandpaper is to get rid of sharp edges, stop you from getting splinters on wood. It's really just to smooth things out. And that's exactly what abrasion does. Abrasion happens all over the place, but the most important places are in deserts and in rivers and streams. So in rivers and streams, the water flows downhill, and that carries rocks, and they tumble down that river, down that stream. And as they tumble, they bump into each other, and the sharp edges of rocks end up getting chipped away. So they start chipping away and slowly, slowly chip away, and they end up becoming super, super smooth and round like this. So they have these tumblers, and like, not in nature, but people have tumblers, which is pretty much just like a barrel that you put rocks in, and you shake it and you shake it and you shake it and you shake it, and you can actually like roll it and roll it and roll it, and the rocks will come out very, very smooth after a while of doing that. It's really like a polishing technique, but that happens in nature. So anytime you see nice rounded rocks, that's caused by abrasion in streams and rivers. Okay? So they become rounded, and if you round something, what happens to its size? It becomes smaller. So they become rounded and smaller. This is a real life picture. You can see all these rocks here are nice and round and smooth. They've clearly been abraded for a long time. You even have a giant boulder back there, which is super, super smooth. A different type of physical weathering. Remember, physical, where we're actually breaking things apart. In this case, we have frost action. So this is a really good example down below. You can see that in order for frost action to happen, first you need little cracks in a rock. You need little micro cracks, little tiny cracks, in order for water to seep in. Once that water seeps in, it'll get stuck there, and at night in cold places, sometimes the temperature drops below freezing. So if you have water inside of a rock and it drops below freezing, that causes the ice to expand. So when water freezes, it expands in size. This is why you could take a bottle of water, put it in your freezer, or fill the bottle of water completely with water so there's no air bubbles in it, put it in your freezer, and that water bottle will expand when it freezes. So if you get water inside of a rock and it expands, it's going to make those cracks even bigger. An example where we see this all the time, roads. Go down to Florida, where it doesn't really freeze that much, and their roads are super smooth, no potholes. But come to New York, where our temperatures are always fluctuating between below freezing and thawing, freezing and thawing. Thawing is where we melt. That is when we have these cracks in our roads opening up and actually making huge potholes where huge areas of the road are released. All right? So frost action occurs in cold but wet environments. This is a picture that I took with my nasty hand, but you could see how this is actually ice. This is not a rock. This is ice. This chunk of ice. You can see there's a bunch of mud up here and there's a bunch of mud down here, and the ice has actually split that. So this mud used to be connected to here, but it's actually been grown and separated. This is the quarter for New Hampshire. It's a mountain that looks like a face. This is what it looked like, and this is what it looks like now. So they can thank frost action for ruining their quarter in New Hampshire. It looked like a face, the nose fell off. Man in the mountain. Oop. Okay, sorry about that. Okay, next is going to be exfoliation. Exfoliation, not the most common thing on the regions. I've never really seen it, but I'm still going to go over it. The idea is that the sun heats the top of a rock. So the top of the rock is going to be heated, and we know when things heat up, they become less dense and expand. So if the outer part of the rock is expanding while the inner part of the rock stays cold, that expansion is going to cause the outside to end up cracking off. And you can see how it's cracked off and flaked off. Just like how you exfoliate your skin, where you use little pieces of sand or little abrasions to get the dead pieces of your skin off, this is very similar, where we flake off the outer layer of a rock. So exfoliation is just caused by heating the outside of a rock, which causes it to expand and break off of the rock beneath it. Okay, So these are all images of exfoliation. Next is one of my favorites, root wedging. Root wedging happens all the time around here. It's when there's a little crack in a rock, a seed falls on there and starts to grow into the rock. Its root starts to grow into the rock. You may not think it, but trees, through their slow growth, can break almost anything. And in this case, they're breaking giant boulders, and they're separating them by having their roots dig down deeper and grow wider through them, causing these rocks to stretch and stretch and stretch and end up breaking physically. Physical abrasion. Okay, so that's called root wedging or root action. These things, lichens, you can see them on rocks. They're the first example of root action. They actually formed our first soils. Thank you. And you can thank root action for destroying sidewalks, giving you jumps for your bike to go off of. Root wedging again, a whole tree growing out of a rock. And now we're going from physical weathering to chemical weathering. We're almost done. Thank you for listening. Thank you for paying attention. Chemical weathering causes things to look really cool. So what I always look for chemical weathering is, did it change color? If it changed color, that's a chemical reaction for the most part. Does it bubble or fizz with a liquid put on it? That's an example of a chemical reaction. If we're making a substance into a new substance by changing its color or by making it bubble and fizz and turn it into a gas, that's how we know a chemical reaction is occurring. So chemical is just a chemical change. My favorite one, oxidation. Oxidation is going to be what we call rust. So it's the idea that a metal, when it's exposed to air, actually reacts with the air. The air will either attach onto it or it will pull pieces off of it. For the most part, it does attach onto it through this process of oxidation, which is where we have metals that rust, and these are actual rocks here that used to be like a gray, and now they're like this yellowy orange, this rust. Another good example of oxidation is the Statue of Liberty. This is a copper Statue of Liberty, and this is a copper Statue of Liberty. This is actually what the Statue of Liberty looked like when we first got it. And not many years later, just like a penny, you ever seen a penny that turned like green-blue? The copper turns green-blue, so now it looks like this. If you went up to this and you scraped away some of that outer layer, you would find the copper underneath it. So it did look really cool back in the day. It looks really cool today, and it's chemical weathering, oxidation. All right? So the other one is dissolution or dissolving. So when we put salt in water, right, and we mix it up and it kind of disappears, it doesn't disappear, it goes into solution. It dissolves into the actual water. So in areas where we have limestone, limestone dissolves with acid. So does calcite, because calcite and limestone are the same thing, just that calcite is a mineral name, limestone is a rock name. So this is a cave of limestone, and the limestone dissolves because of acidic water. So as the water runs through little cracks in the limestone, it dissolves it more and more, making those holes bigger and bigger until they become giant caves like this and like this. All right, so this used to be a tiny crack in a rock, and it dissolved until it's become this huge cave. And you can imagine this whole area filling up with water from time to time, dissolving more, and then rushing out eventually as it finds its way out of the cave. So that's how caves form. Feel free to watch this video. I just want to end this with this diagram here, weathering determined by climate. So if you think about it, what we've talked about is warm climates, cold climates, and water. Water is a huge part of weathering or breaking down rocks, whether that's happening in a stream where they're abrading against each other, or whether that's happening where water is a little acidic and it flows into limestone and dissolves those cracks, right? That happened in a warm environment, because caves are usually in warm environments, because chemical reactions like heat for the most part. But we could also talk about a cold environment, a wet and cold environment, like in New York, where we have water that seeps into cracks, and then at night it freezes and those cracks open up. All right? So if we look at this chart, cold temperatures, Where we have a lot of precipitation, you'll see we have strong frost action where we have high amounts of precipitation. But if we enter warmer climates, where it's dry, where we don't have much precipitation, not much precipitation, but a warm climate, like a desert, we don't have much weathering, because that's mostly going to be the wind. But water is the thing that really does a lot of the weathering. So if we enter a wet and hot climate, we'll see that we have moderate to strong chemical weathering occurring. This would be like areas where we have caves, hot and wet. Areas where it's wet and cold, we have a lot of frost action. And throughout all of this, wherever there's a river, wherever there's a stream, there's abrasion happening. Okay? Hopefully this was good. Hopefully this made sense. Thanks for watching. Anyone who is watching. You can go on to Nearpod now. Here are the codes. If you can't see that, here are the codes for Nearpod. Period 1 is going to do RQXBL. Period 3 is going to do JMUTA. Alright? Thanks for watching. Let me know how it is.